Math 1314, Tyler Junior College, section 3.5, rational functions, graphing via transformations. In a previous series of videos for, I believe, section 2.5, we discussed how to take the graph of a function and transform it by either translating it left, right, up, or down, possibly reflecting it over the x or the y-axis, and also possibly stretching or shrinking horizontally or vertically. I'm going to spare you the stretching and shrinking and just show you some examples of transformations involving translations, so moving up, down, left, or right, and reflections, either across the x-axis or the y-axis. But before we do that, let's take a look at a couple of common functions graphs. This one, the reciprocal function, we had seen previously. The graph had two branches, one in quadrant 1 and one in quadrant 3. There was a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. And based on the discussions that we've recently had, that makes sense. 0 makes the denominator 0, vertical. The degree in the denominator is greater, horizontal. But here's one we haven't seen before. It's called the reciprocal square function, or the squared reciprocal function, 1 over x squared. It's kind of like 1 over x, except the branch in quadrant 3 is now in quadrant 2. That's easy to explain. When you square a negative, it becomes positive. In quadrant 2, x's are negative, but the y's are positive. The asymptotes are the same, the x and the y-axis, if you will. And on both of these, I put two reference points, one for each branch. On both of them in quadrant 1, 1 comma 1 is a reference point. But for the reciprocal function, negative 1 comma negative 1 is a reference point. For the reciprocal squared function, negative 1 comma 1 is a reference point. And although we don't need it to sketch the graphs, it's worth mentioning that the reciprocal function is an odd function. You can check it algebraically with the definition, but visually this has origin symmetry. And the reciprocal squared function is an even function. You can check it algebraically, but visually it has y-axis symmetry. So, let's graph these two. Starting with f of x equals 1 over x plus 2 plus 3. Recall that if you add a number to the end of a function, it invokes a translation in the vertical direction and does what you expect. This plus 3 will move the graph up 3. But when you add or subtract a number directly to the x, it invokes a translation horizontally, but the opposite of what you expect. If I said move horizontally and said plus 2, you would think right 2, but it actually moves to the left 2. No negatives, so no reflections. So we have to take all the pieces of this graph, move them up 3 and to the left 2. Let's start with the asymptotes. The asymptotes should be drawn first because you sketch your graph around them. Let's start with y equals 0, aka the x-axis. If we move that to the left 2, it's still on the x-axis, but then if we move it up 3, then it's up 3. So 1, 2, 3, and we will have a horizontal asymptote at y equals 3. Now be careful, we can't apply the horizontal asymptote test to this because this is not just a ratio of polynomial functions, it's a ratio plus a third number. So if you're wondering why is it y equals 3, shouldn't it be y equals 0? Get a common denominator, add the fractions, and you'll see why. But right now, don't overanalyze it. Just take the current horizontal asymptote, move it up 3. Concerning the vertical asymptote is at x equals 0. When we move it to the left, it's over at negative 2, and then moving it up or down doesn't change it. So our vertical asymptote, moving to the left 2, is now at x equals negative 2. Let's keep track of the reference points. For 1 comma 1, we're going left 2 and up 3. That's like subtracting 2 from the x and adding 3 to the y. 1 minus 2 is negative 1. Let me write this. The point 1, 1 will become the point 1 minus 2, 1 plus 3. Minus 2 because we went left 2, plus 3 because we went up 3. So that point will become negative 1 comma 4. Negative 1 comma 4. Right there. The other point, negative 1 comma negative 1, I know I'm using the arrow, which means approaches, but I don't want to say equals either. We'll just say this arrow means changes, so hopefully nobody's going to roast me over the coals for that. If we take the other reference point of -1, -1, move it to the left 2, we would subtract 2 from its x. Move it up 3, we would add 3 to its y. -1 minus 2 is -3. -1 plus 3 is 2. We have a point at -3, 2. And then reconnect, or rather redraw. We're not really connecting anything here. So the same as before. Figure out the transformations and apply them to every piece that you're looking at, the asymptotes, the branches, and the reference points. For the second one, we can do the same thing. What does the negative in front invoke? A negative in front of the function invokes a reflection across the x-axis. A reflection across the x-axis. Excuse me. And subtracting a 2 from the x invokes a horizontal translation, but the opposite of what you expect. So this +2 actually moves the graph to the right 2. This time, let's see if we can just draw it. Since we're moving to the right, the horizontal asymptote isn't going to change. If I take this horizontal line and move it 2 spaces to the right, it's going to be in the exact same place. So the horizontal asymptote will still be at y equals 0. But the vertical asymptote, the one at x equals 0, will move to the right 2. So if I grab this red dotted line and move it to the right 2, then it's going to be at x equals 2. X equals 2. The reflections don't change either of those asymptotes over there. For the points, when you are doing reflections and translations, the reflections take precedence. The general strategy is get the shape correct and then move it around. If we reflect both of these points down here, then their y-coordinates would just have a -1. And then moving them to the right 2 would add 2 to the x-coordinates. So I'm going to add 2 to each x, but stick a negative on its y. If I add 2 to the first x, I get 1. And if I put a negative on its y, I get -1. So our first point of reference moves to 1, -1. The second reference point, if I add 2 to its x, I get 3. If I put a negative on its y, I get -1. So my other reference point is now at 3, -1, and then redraw the branches. So it's just like we did before. Move stuff around, turn stuff over. I'm just going to spare you the stretches and the